Okay, it's working out. All right, so week 7, notes 2, ellipses. So let's talk about an ellipse and what basically that is. It is basically an oval. Okay, what is an ellipse? It's an oval. So which we're going to analyze. We're going to analyze the oval that the ovals that we will draw today. So if you could try to draw your best oval there. So the ellipses that we're going to be studying have different parts to them. They have what are called a minor axis. Okay, the minor axis goes right through the center. The center of the ellipse is right here. So it's kind of like a squashed circle a little bit. If you think about it like that, ellipses have a center just like circles have a center. And so this right here, this is called the minor axis. Okay, and this distance right here from the center to the basically the side of this ellipse right here, this is a distance of b. Okay, that's a distance of b. All right, we're just very basic right now, very basic. And then we have the major axis, which basically connects through this way, and major and minor axes kind of intersect at a right angle right there. And the distance from the end of the ellipse there, where the major axis intersects the ellipse through the center right there, that is called a distance of a. Okay. So the half, you need to see this, that half of the major axis right there is a. So the whole major axis would be a distance of 2a. All right, so this is all a distance of 2a right there. And then the entire distance or length of the minor axis of an ellipse would be 2b. Okay, so understand 2a and 2b. So the 2a is always the major axis. So this is an important part of an ellipse, and that is this, that a is always greater than b. So we have an a value, we have a b value, and then we also have a c value, and the c value is similar to the parabola. The c value is the distance from the center of the ellipse to the focus, and there are actually two focuses, and if we have multiple focuses, we call them foci. All right, foci. So this right here is a focus. This right there is the other focus. These are both foci right here. And the distance from the center to the foci is going to be a distance of c. So right here, this distance is a distance of c. All right. So having said all of that, there is actually a relationship between A, B, and C. And this isn't a relationship that you're going to need to memorize, but just get the picture of this in your mind. We need some way to identify the length of A, this length, the length of B, this length, and we need some way to identify C. But the relationship between all three of these, the A, B, and the C, is this. It looks similar to the Pythagorean theorem, but it's A squared minus B squared equals C squared. Now this is a math fact that can be proven, but you're not going to be expected to do that at that level of rigor in this class of why this is true, but this is actually true, just like the Pythagorean theorem is true. But this applies to ellipses, and you need to understand that there's a minus there, and that minus is what makes this the equation for an ellipse, to see the relationship between A, B, and C. You have a minus in there. It's not a plus. So understand that that is a minus for the third time. Okay, now, I said that A is always greater than B, so therefore sometimes you can have ellipses that are kind of squashed, but they're kind of going in this way, in this direction. In that case, right here, this would be the major axis, if I could draw a straight line, which I didn't, but it's close enough. And then this would be the minor axis. So therefore, this would be A, the distance from the center to the edge of the ellipse there. This would be A as well, and then this would be B, this would be B, and then the distance from the center to the foci would be C as well. So same deal there. Right there, that would be a distance of C. And the relationship is the same. So sometimes you have an ellipse that kind of goes like this. Sometimes you have an ellipse that goes like that. You can also have an ellipse that's rotated, and then we're getting into like trigonometry and stuff, which we don't need to know yet. But the basic equation for an ellipse is very similar to a circle. If you remember the circle, it was basically x squared plus, or x minus h squared plus x minus k squared equals the radius squared. Well, in this case, the equation for the ellipse, at least an ellipse that is centered at 0, 0, is the following. So you have x squared, and you're going to have each one be a fraction. So this is going to be x squared over a squared plus y squared over b squared equals 1. So really focus in on this equation right here and this equation. These are both very important equations. This is the equation you're going to really be working with. This is your equation that allows you to graph it. This equation helps you because it helps you see the relationship between the length of the major minor axis and the distance from the center to the foci, i.e. C. Okay, so let's do an example here, right here. So you guys actually have homework, which what we want to do is identify A, B, and C from the given equation, and then graph the ellipse with the vertices and foci. So let's just say I give you an equation that looks like